Hello friends, good morning. In today's video we will solve two numerical problems which are based on the pressure variation in fluid at rest. So as an example you can see that there are two fluids, water and oil, kept in a vessel, and this is open at atmosphere at top. So we will find the vertical variation of pressure inside this fluid. So let's solve the first question first. Let's move downwards. Calculate the pressure due to column of 0.3 meter of. There are two cases, A and B. Water, A is water, and oil. Specific gravity of oil is 0.8 and mercury of specific gravity, and third case is mercury. Specific gravity 13.6. Take density of water. Density of water rho is equal to 1000 kg per meter cube. So what will be the density of oil? Then specific gravity is density of fluid divided by density of water in case of liquids. In case of gas it is density of air. So specific gravity is 0.8 is equal to density of fluid we have to find, density of oil, then density of water is 1000. So density of oil will be 0.8 into 1000 is equal to 800 kg per meter cube. Similarly, density of mercury is equal to 13.6 into density of specific gravity to density of water, which is 1000 kg per meter cube. So it is 13,600 kg per meter cube. So we have to calculate pressure due to column. So suppose this is for first case, this is water. Suppose this is a glass and water is filled in this, and height of the column is given as 0.3 meter. This is height. So what will be the pressure at bottom? We have to calculate pressure at bottom here. So what will be P at the bottom of the glass? So P will be, we know the formula, rho G into H. You can remember this formula. Due to depth variation or variation in the height inside the static fluid which is not pressurized from outside, the pressure will be rho GH, where rho is density, G is acceleration due to gravity, this is density, this is acceleration due to gravity, which is 9.81 meter per second square for earth, and H is height of the column. So for water it will be, pressure will be rho, which is 1000 into G is 9.81 into height is 0.3. So if you will multiply this, you will get 2943 Newton per meter square. This is pressure. Now for oil, what will be the pressure? For oil, pressure will be rho GH. Density of oil is 800 into gravity, acceleration due to gravity is 9.81 into height is 0.3. So if you multiply these three, then you will get 2354 Newton per meter square. Now for third case, P will be, in case of mercury, rho GH, which will be equal to 13,600 600 is density of mercury into G is 9.81 for all the cases and H is 0.3. So if you will multiply, you will get 40025 Newton per meter square. Now let's move to the second case. In first case there was only one liquid, and in this case there are two liquids, oil and water. So let's see the case. An open tank contains water up to depth of 2 meter. So this is 2 meter height of water, and above it is specific gravity 0.9 for a depth of 1 meter. So this is oil of a specific gravity 0.9 and its height is 1 meter. Find the pressure at the interface of the two liquids. So we have to find at this point 1 and second at the bottom of the tank. So at these 2 points we have to find the density of the pressure intensity. So we have already calculated, seen that formula of pressure is rho GH. Okay, rho is density, G is acceleration due to gravity, H is height of the column. So at this point interface we can say that pressure is acting due to only oil is above this point. So at interface pressure will be only due to column of oil. So pressure at one point will be, density of oil is C, specific gravity is 0.9. so density of oil will be specific gravity into density of water. So this is density of oil into G is 9.81 into height of the column is 1 meter. So if you will multiply these three, you will get 8829 Newton per meter square. Second, we have to find at the bottom of the tank. So at the bottom of tank at point 2 we will be having pressure due to oil column plus liquid column both. So P2 will be rho GH for oil plus rho GH for water. So rho GH due to oil we have already calculated, which is 8829 plus this due to water column is density of water is 1000 into gravity, acceleration due to gravity is 9.81 plus height is 2 meter. So you will get 8829, this is already calculated, plus this is multiplication. If you will calculate this, you will get 19620. Okay, so you have to add these two, then you will get 28449 Newton per meter square. So this much will be the pressure at the bottom of the tank. Okay, so I hope you understood these two problems. If you have any doubt, then you can ask in the comment section, and thanks for watching this video.